Hello everyone, my name is Jitendra Chok and I will be teaching Symmetry and Group Theory course in this video. So before we actually go on and start with lecture 1, let us first look at the course contents, prerequisites, etc. So let me first list down the prerequisites for this course. Prerequisites of the course. So it will be highly beneficial if you have already gone through general chemistry 1 and in particular physical chemistry component of it. Also, it will be beneficial if you have gone through fundamentals of molecular spectroscopy. Once you have taken this course becomes an excellent prerequisite for if you're going to take, let's say, this course is a prereq for quantum chemistry, if you are going to take quantum chemistry course, and if you are going to study advanced molecular spectroscopy. Okay, so now let us also look at the books which I'll be following. So one of the book is Chemical Applications of Group Theory. This is by F.A. Cotton. And the second book which I'll be following is Molecular Symmetry and Group Theory. This is authored by R.L. Carter. So any other book also, if you follow, one of the major point which you have to take care, let's say if you are following multiple books, some of the books carry or some of the books actually carry out rotations in clockwise direction, and some of the books carry, so this course is about symmetry and we'll be doing a lot of rotation of molecules. So some of the books carry clockwise rotations, other books carry anti-clockwise rotations, so results may differ out if you are following multiple books for a given set of problems. But if you keep following the same notation or same orientation all through, then it should not matter. So we'll see this in more details when we'll actually come to rotations and all. uh, let's also list down the course contents. The course content of this course, I will start with introduction. In lecture 1, this will be followed by defining symmetry elements, and symmetry operations. This will be followed by shown flies, notations of point groups, then we will have definition of group, subgroup, and class. Once we have done this, we will actually do our very first application of group theory, which will be predicting physical properties like dipole moment and optical activity from the viewpoint of symmetry. Then we will be writing matrix representations of point groups. So if you have not gone through matrices course in a long time, so I would request you to brush up your basics of matrices. Reducible and irreducible representations. One of the very important theorems in group theory, which is called as great orthogonality theorem and its corollaries. Then we will be constructing character tables. Construction of character tables. And meaning of various terms in character table. This will be followed by Mulliken symbol for irreducible representation. Direct product this is direct product of irreducible representation. So I'm writing this in short form. So this is irreducible representation. Application to spectroscopy. So it will be beneficial if you have already gone through a spectroscopy course, but I will be covering a little briefing about spectroscopy, so do not worry a lot, but still, it will be better if you have already gone through. Another important concept in group theory is projection, operator, and its applications. To symmetry adapted linear combinations. Application to quantum mechanics. And last will be construction of molecular orbital correlation diagrams of simple and complex molecules. So we have discussed today the prerequisites of the course, the books which I'll be following, and the course contents. So that's all for in this video, and let us see you in next video where we will start with lecture 1.